Hello, this is example 2 of sketching rational functions. First things first, is there anything I can factor here? I can factor the denominator. It's a difference of squares, so I can do x plus 1, x minus 1, and there it is in factored form. Step 1 from our previous video, step 1 is find the y-intercept, and we said that to find the y-intercept, we're going to evaluate our function when x is equal to 0, and that we do with the original function. We get 0 minus 2 over 0 minus 1, which is equal to negative 2 over negative 1, which is positive 2. That means that my y-intercept is located at the point 0, 2. Second step, find my zeros or my x-intercepts. Okay, x-intercepts. And we said that we take the numerator and we equal it to 0. So my numerator is x minus 2. X minus 2 equals 0. That means x is equal to 2. That will be the only x-intercept in my graph. Number 3, vertical asymptotes. Vertical asymptote, we said that we're going to take the denominator, and here's my denominator, the factored form of the denominator, and we're going to equal that to 0. X minus 1 equals 0, and we use the zero product property. That means x plus 1 equals 0, x minus 1 equals 0. And then we solve for x. So x will be negative 1, x equal 1. These are my two vertical asymptotes. For the horizontal asymptote, remember we're going to look at the degree. The degree in the numerator is 1. The degree in the denominator is 2. That means that the degree in the numerator is less than the degree in the denominator. And we said that when that happens, my horizontal asymptote is going to be y equal to 0. That's your horizontal asymptote. And y equal to 0 is your x-axis. Okay, your x-axis. And the next thing we're going to do is we're going to do the sign analysis. So I'm going to draw a number line here. This is step 5. And we're going to do our sign analysis. What we're going to plot on this number line is the zeros and the vertical asymptotes, nothing else. So our x-intercept or our 0 is at x equal to 2. I'm going to say this is 2 right here. And my vertical asymptotes, I have one at 1. That means there's a wall at the value x equal to 1. And there's another wall at the value x equal to negative 1. So negative 1, and this is 1. Those are my two walls. Notice that these are the critical points, and these critical points divide my number line into 3 regions. I have this region here from negative infinity all the way to negative 1. I have another region that goes from negative 1 to 1, and I have 4 regions. I said 3 regions, I'm sorry. From 1 to 2, and then you have your last region from 2 all the way to positive infinity. So 4 regions. That means I have to test 4 values. Okay, so let's start choosing values. If I have from negative infinity all the way to negative 1, I'm going to choose negative 2. If I plug in a negative 2 here, will this result be negative or positive? It's going to be negative. If I plug in -2 here, will this result be negative or positive? It's going to be negative. And if I plug in -2 here, this will also be negative. Negative times negative, positive. Positive over, or negative over positive, that will be negative. So that means that the graph in this interval will be below the x-axis. Okay? Let's do the second region. From -1 to 1, I'm going to choose 0. 0. If I plug in 0 in the numerator, this will be a negative value. If I plug in 0 here, this will be positive, and if I plug in 0 here, this will be negative. So positive times negative, negative. Negative over negative, that makes this positive. That means that the graph will be above the x-axis in this region. Let's do this interval from 1 to 2. Let's choose a number, 1.5. Okay, if I do 1.5 and I plug it in here, 1.5 minus 2, that will give me a negative number. 1.5 plus 1, that will give me a positive number, and 1.5 minus 1 will be a positive number. So positive times positive is positive. Negative over positive will be negative. That means that in this region, the graph will be below the x-axis. And our last region, from 2 to infinity, you can choose any number. I'm going to choose 3. So when x is 3, will this value be positive or negative? It's going to be positive. When x is 3 here, will this be positive or negative? It will be positive. And when x is 3 here, 3 minus 1, that will be a positive number. So positive divided by positive will be positive. That means that this region, the graph will be above the x-axis. Okay? Now we have enough information to plot or to sketch this graph. So the first thing I'm going to do is I'm going to plot my y-intercept. It's at 0, 2. Here is 0, 2 right here. There's your y-intercept. Second thing is plot my 0. I have a 0 at x equal to 2, so here it is. Here's 2. Okay? The next thing I'm going to plot, going down the list, is my vertical asymptotes. I have one at -1 and another one at 1. So remember, the vertical asymptotes are really walls. Okay, and the graph will not hit against the wall. It will splash up the wall, like if the wall had a sort of a force field that will not let the graph get near it. Okay, here's one of the walls at -1, and here's another wall at 1 right here. Okay, x equal to 1. This is my other vertical asymptote. Okay, my horizontal asymptote we said was at y equal to 0. So we said that would be the x-axis, and all of the asymptotes I like to draw with dashed lines because they're really imaginary lines on the real graph. They're imaginary lines, okay? And that's it. I have all the information I need on my graph. So let's start looking at my sign analysis. It says on here that the graph is coming in from the left, right? It's coming in from the left and it's below the x-axis. That means it's down here in this region here, okay? Below the x-axis, all the way till it gets to that first wall at -1. So I'm coming from under here. Now, do I come from down here? Do I come close from the asymptote? What is it that's going on? Be careful. On our previous graph, we were coming in from down here, right? But for this one, since I have a horizontal asymptote, I know the behavior near the asymptotes is that the graph will approach the asymptotes. So I know that this graph is coming from very close of the asymptote like this. Since there's an asymptote, I know this graph is coming in from very close, and it starts separating from the asymptote. And I know it's negative, so it's down here, it's coming down. And it's going to approach the other asymptote, which is the other wall, and it's going to splash against it, but never touch it. So there it is, more or less. I'm sorry it's so sloppy. Okay, so there's my graph in this interval from negative infinity all the way to -1. Okay? It is below the x-axis. It's very close to the asymptotes at the extremes. Okay? And that's how it will behave close to the asymptotes. Now I go to my second interval, right in between here. It says that the graph will be above the x-axis. And notice that the second interval is the interval in between the two walls. So here it is right here in my graph. This space in between -1 and 1, which I didn't write, -1 and 1, in between these two is where I'm going to move next. And let's see, we say that in between the two walls, the graph is above the x-axis. That means I'm up here in between these two walls. Notice that in between the two walls, the graph will cross the y-axis at the y-intercept. So that can only mean one thing. Remember that near the asymptotes, the graph will splash against those walls. Now the question is, will this graph splash upwards, or will this graph splash downwards? Well, it says here that the graph remains above the x-axis in between those two walls, so it must be positive. That means it's going to splash upwards. Okay, it splashes against the wall upwards. It crosses the y-intercept and splashes against the other wall. There it is, sort of like a parabola. We're done with this area here. Let's go to our third region, which is from 1 all the way to 2. So in between here, this value and this value, right? One little square. What happens in between these two values? It says here that the function is below the x-axis. That means I'm down here negatively. Notice this is behind the wall. So what's going to happen near the wall? Well, I know what happens. The graphs, when they're near the wall, they approach the wall. They get closer and closer and closer to the wall, never touching it. And what happens? It remains below the x-axis till it reaches that 0, which it will cross. Notice that right here where I have my 0, I will cross the 0. And when I cross the 0, what happens to the function? After that number 2, after that value, the graph will be above the x-axis. So that means this will become positive now. Now notice, stop right here. Remember this horizontal asymptote. Horizontal asymptotes we can cross, we can touch. The only ones we're not allowed to cross or touch are the vertical asymptotes. So remember the behavior of the graph near the walls, the asymptotes. This graph will cross, become positive, but it will not go all the way up. It will remain near and get closer and closer to that asymptote. It's going to splash against this wall. And there's your graph. This is beautiful. I hope you understood. I'm going to show you this graph in WZ Grapher so that you have an idea of what the graph looks like in reality without the asymptotes. Okay, here is the graph in WZ Grapher. Notice that from negative infinity all the way to my first wall, which is about here, x equal to -1. Notice you don't see a wall really here, But by the way the function, let me scroll down, by the way the function is behaving, I know there's kind of something there stopping the function from approaching the y-axis. And if I go further down, you see that? That means that this function, there's an asymptote there, and it's about at x equal -1. The other wall is x equal to 1, about here. Okay, let me move this. About here, x equal to 1. You can see an imaginary wall here. You can see an imaginary wall at this sort of like a parabola. It's not a parabola, but you can see the y-intercept happening at y equal to 2 right there. Right there. Okay, more or less. And you can also see where the graph crosses the x-axis. We had said that at x equal to 2, the graph will cross the x-axis, become positive. But notice, it stays very, very, very close to this wall. And it will get closer and closer, but will never touch the wall. Okay? It looks like it touches it, but it's because of the resolution. If I zoom in, you'll notice that it is not. It will never touch it. So this is very similar to what I drew, right? Let's go back to what I drew. Here it is. Where is it? Right here. There it is. Okay, so it's a pretty good sketch. I'll see you in the next video for the next example.